So till now we have been designed for the given load. What is the load power required? Already we have done it. So load power is how much? 370 watts. For this much amount of power rating, what is the rating of the inverter we required? A 100 VA inverter is designed, and the system voltage of this inverter is how much? 12 volt system. So for the given load of 370 watts, we designed an inverter. Rating required is 400 VA inverter, and the output of the inverter is connected to the load, and input of the inverter is connected to the charge controller. So already we have been designed. So what is the rating of the charge controller? 34 amperes. So charge controller, we need to select the operating voltage is 12 volts, and the current rating of the charge control is for 34 amperes. So the voltage rating of the charge control is 12 volts, and the maximum current it has to withstand is 34 amperes. So we designed for the given load, we designed inverter, and we have been designed charge controller. Next, what you have to design is the battery size, or how much AH rating is required to withstand the load of 370 watts. What is the power? What is the energy at the load? 2000 2250 2250. So what is the inverter capacity? 24. So you have to multiply this one now by 0.9. How much? 2420 watt hour. So this is also watt hour. So these are the energy requirements. Now we want to design the capacity of the battery. So while you are designing the capacity of a battery, the capacity of a battery is expressed in ampere hours. You already know it. So the capacity of the battery required is equal to energy input to the inverter multiplied with the number of days of autonomy. Sir, what is this autonomy? Autonomy means the number of days in a given year when solar energy is not available. So how many days solar energy will not be available? Let us take that the number of cloudy days in Andhra Pradesh. In 365 days we don't have any cloudy days. Let us assume that only in 365 days we have only 2 cloudy days due to some cyclone or something. So I am concluding, taking an example here, only 2 days is the number of days of where we have the cloudy days divided by, and we are discussing about these batteries. These are solar batteries. These solar batteries have an discharge rate or depth of discharge of 50%. What is the system operating voltage of our system? 12 volts. Okay, we have to substitute this. Okay, so now the energy input to the inverter. So what is energy input required by the inverter? Load requires 2250 watts, but to supply this much amount of energy, what should be the rating of the inverter? 2420. Okay, therefore the energy input to the inverter is 2420 watt hour. This watt hour I can write down it as volt ampere hour multiplied by number of cloudy days. How many days are there? Let us take 2 days we have cloud divided by what is the depth of discharge of the battery in an solar battery? 50%. 50 divided by 100. How much? 0.5 into what is the system voltage given? 12 volts. You see here voltage will get cancelled out automatically. What are the resultant you are going to get? So the battery capacity we will be getting in terms of ampere hour. Do this calculation. 2420 into 2 divided by 0.5 into 12. 8067. So I am taking approximately this one as some 800 AH. 800 AH. So I want to design the number of batteries to be required to be connected in series. Okay. So what is the system AH? The system AH I require is 800 AH divided by individual AH. I am taking a battery. Each battery I am buying in the market with a system voltage of how much? 12 volts and a capacity of 150 AH. Now 800 divided by 150 AH. How many batteries you require? 5.33. So approximately I am rounding this as 6 number of batteries are to be connected in parallel connection. Why? Because so each battery voltage is how much? 12 volts. Individual battery is how much? 150 Ah. 150 Ah battery, how many numbers? 6 numbers we have to connect in parallel in such a way that it can supply the resultant AH of how much? 800 or it will give 900 AH. Okay, why? Because we approximated this 5.3 to 6 number. Now successfully we designed for a given load, we designed the inverter rating of 400 VA, energy input is 2420, what is the rating of the charge controller? 12 volts, 34 amperes. Now what is the battery size? How many batteries you require? 150 Ah battery, which are called as C10 batteries. Like that, how many batteries are required? 5 batteries or 6 batteries. I am taking 6 batteries to make an system of 800 Ah, or generally is 12 into 5 is nothing but 900 Ah. So to supply this load, how many batteries are required? 6 batteries. They should be connected in parallel to supply an Ah capacity of how much? 900 Ah. So now successfully we designed 4 components. From 4 components, the next component what you have to design is our solar panels. How many solar panels are required? So coming to here, the design of solar PV modules. I am taking the type of technology used in the solar panel or the efficiency of the battery. I am taking it as 90%. Efficiency of the battery I am taking it as 90%. Now I am going to define the energy input. So efficiency is equal to output power or output energy divided by input energy. So what is the output energy of the battery? So output energy of the battery is how much? 2420. So the output energy is 2420 watt hour is. So output of the battery will be given to the input of the charge controller. The output of the charge controller will be given to the inverter. Okay. So the output of the battery should be given to the input of the inverter. Therefore, the energy output is 2420. And what is the efficiency of this battery? I am taking this as a 90%, 90 by 100, 0.9. So multiply this term, 2420 divided by 0.9, 2688.89 watt hour divided by watt hour. So you see here, so this much amount of energy has to be supplied by what? Solar system. Which has to be supplied? So solar system has to supply an energy of 2688.9 watt hour. So watt hour I can write it as volt ampere hour divided by sunshine hours. Okay, generally in Andhra Pradesh we have the sunshine hours maximum 6 hours, but we'll try to calculate throughout India. On average the sunshine hours we are taking it as 5 hours strongly. Okay, so divided by 5 hours. So 5 hours will get cancelled out. The resultant will be in terms of volt ampere. So calculate, or it will be in watts. So 2688 divided by 5. 2688 by 5. 530.7. I mean 8 I am writing. So I require 537 watt solar power rated. Okay. So hope the things are very clear. So what is the way of designing a solar PV system? First we should know what kind of load we have. From the load we have to calculate the rating of the inverter. From the the output of the load is supplied by the inverter. So what is input to the inverter? That is given by the charge controller. The input to the inverter is given by the battery output. Okay, battery input is given by solar input. Okay, so to supply this, how many solar panels you require? So this is 537, make it as 600 watts. How many watts? 600 watts. Then how many panels you require? 6 solar panel. Okay, so to supply this I am taking I have hundreds, a 100 watt solar panel. So how many number I require? 6 solar panel of 100 number I require to supply this much amount of load. Okay, now let's try to have an overall view to discuss this. So first what have been designed? First we have been designed the load. As per the given problem, how much amount of power rating is required by the load? So 370 watts is your load and it requires an energy of 2250. To supply this amount of load, input should be given. How much amount of input energy should be given to the inverter? So this is inverter. second one is nothing but the inverter to supply this much amount of output. How much amount of input has to be given to the inverter? So I have given an input of 2420 watts is the input energy I have to supply to the inverter, such a way it can supply an output of 2250. And what is the power rating of the inverter I require? 400 VA rating. And what is the system voltage of this inverter? 12 volt system. So now we are coming in this fashion. From load we calculated the inverter rating. Now what is the input to the inverter? Charge controller. Okay, so we have a charge controller. So coming to this charge controller rating, what is the voltage rating? 12 volt system, and current rating is how much? 34 amperes. So now we designed the charge controller. Now what is the input to the charge controller? Battery. So you have a battery. The output of the battery will be given to the charge controller. Okay, so then what is the input to the battery? Solar system. Okay, so solar system is the input energy to be supplied by the solar. So by taking this input energy, it can deliver an output of 12 volts and 34 amperes. Therefore, what is the rating of the battery you require? 800 Ah capacity battery you should be there. Then how many batteries you require? 150 Ah battery into how many numbers? 6 numbers. In such a way it can supply 800 Ah or 900 Ah of this required load of 370 watts and 2250 energy. So to supply this much amount of ampere hour rating, what should be the rating of the solar system? 600 watts. So 600 watts can be supplied by an 100 watt panel of how many numbers? 6 number connected in series connection. And what is the output of this? What is Vm and Im of the solar panel? Vm will should be 12 volt system. We can see here this complete system, which kind of system? Solar system of which kind? 12 volt system. So since it is less than 1 kVA, okay, you can see here the rating of the panels are, the rating of this, all the parameters are less than 1 kVA, it will come under 12 volt system. If you get the calculation, you get some sort of 1200 or 1500 or 2000, then you have to go for an operating voltage of how much? 24 volt system. So for this system, for the given load as per the problem, how many voltage system is required? 12 volt system is sufficient. And what is the rating of the charge controller? 34 amperes. What is the rating of the battery? 800 Ah capacity is required. Then 150 Ah batteries of 6 number has to be connected in parallel. To supply this much amount of Ah, what should be the energy input to be supplied by the solar? 600 watts. So this is how we had been came in the reverse engineering to understand this flow. Hope this is how to design a solar PV system for a given load of 370 watts as per the given problem. Okay, now let's try to do one more problem, then you can have more experience. Okay.